sure about that?
Yeah, haven't heard that yet.
There you go. But it got burned yesterday.
Yeah, thank you. Here you go.
Kevin, how'd you get me that? I saw you eating. Yeah.
Here.
Ooh, that's the bird after work.
You don't know if you're going to grab one of them.
Now, we go
Yeah,
over
I'll do
there.
this thing.
Okay?
Wait.
It was like 2 days ago.
Okay. Guys,
Guys,
we're getting ready. We're starting. Okay, exponential transformations. I want to do this and get it done, and then you'll have some free time. Okay? Okay, you have your windows set at x-min is -6, x-max is 6. Where's my calculator?
Hey, is this the same stuff we've been doing?
No, this is a little different today, but it's still exponential. I gotta clear out my calculator. Clear out my. Okay. You have one for the x scale and one for the y scale. I'm sure that those are like that. Okay. What we're going to do is graph these functions on the left after we write them, write what they are, and see when they've already graphed them for us. We're going to go ahead and graph them too and see what happens. So we've got A is 1 and B is 2. Why is A 1 here? I don't see a 1 over there. Where'd they get the 1 from?
The little number?
Okay, well,
Maybe because there's only one of them. Like if it was like x squared, then it would be 2.
Why is just one of them?
Don't you have to have
It's one Y.
you have to have there's supposed to be an A here, and there's not a number in front of there, is there? No. So
It's a
there's
one.
it's a 1. It's like 1 times 2 to the x. That's what that means.
Yes.
Okay, so there's not anything here either, so what's the A?
1,
Times
3,
this one?
1, 1, 8.
There you go. Okay, and the A is 1. Okay, what's the B?
3.
3 and
Eight.
8. Okay. So we're looking at the A's. What do you notice about the A's?
They're all the same.
They're all the same. What do you notice about the B's? What's happening with the B's? They're increasing. So we're going to see what happens when A stays the same and B gets larger. Okay? And to put this in, all you have to put in is 2 to the x. You don't have to do 1 times 2 to the x. So we'll do 2 to the x, and then in y2 we'll put 3 to the x, y3, 8 to the x. And then when you graph it, watch what happens, because you want to see what happens from your first one to the second one to the third one. Takes it a while.
You know Steve?
Is it?
Yes.
Yeah.
Looks like it got steeper, didn't it?
Mm-hmm.
Okay. What point is it going through?
Just 1.
It looks like
It's going through 1.
0, 1, 1. I think it's 1.
Definitely going through.
It's going through 1 because what is A?
oh, it's 1.
A is 1. That tells you where it's going through. Okay, so we can say as B gets, or let's say as B increases. The graph gets steeper.
What about vertically inclined?
Vertically stretched.
Stretched.
Yes,
Yeah.
that would be good too. The graph is vertically stretched. That's a good. Okay. And is all the B's are greater than 1. So this is for when B is greater than 1.
Yes.
Because the next one, all the B's are going to be less than 1, aren't they? Okay, so we're going to see what happens when B is less than 1. So down here on this one, this would be 0.4. This is 0.1. And what are the A's again?
1.
1. There isn't an A out here, so it's 1. So the A's are staying the same. Where do you think the graph is going to go? What is going to be the y-intercept?
Again.
Where is it going to go through the y-axis at? 1. Okay. So let's try these. See what happens. Whoops, 0.6, isn't it? You really don't have to have parentheses on this, but since they put it, we'll put it too. Once you get in there, go ahead and graph it, see what happens. What are the graphs doing? You want to get some water?
Okay, punish us.
Okay. Okay, the graphs are doing what? They started out here, and now they're getting
It's closer to 0.
steeper. They're getting steeper again. Okay. Or what's the other name for it? Vertically stretched. Okay. Y'all paying attention?
Yes.
Okay. So let's graph them. They're not that easy to graph, but do your best. Okay, now B was less than 1, and how is it different from when B is greater than 1? How are the graphs
It
different?
goes the other way.
Yeah, it goes the other direction. What is this called when it starts up and goes down?
Decay.
Okay, what's it called when it starts down and goes up?
Growth.
Yes, growth. Okay, and B is less than 1 on decay, and B is greater than 1 on growth. Okay. And the graphs as, what happened to B? Did it get smaller or larger?
It decreased.
It decreased, okay? So as B decreases, the graph gets steeper, which was different from the other one, wasn't it? So when B is less than 1, when it's decay, and as B decreases, the graph gets steeper. Okay, now this is not something that you have to memorize, okay? I just kind of want to show it to you. Now the next ones are a little more important. Let's see what happens in set 3. First of all, what in the heck is that E over there? Anybody know?
Variable.
Yeah, it's actually a button on your calculator. Have you seen it before?
Yes.
Where is it?
It's up there with LN.
Yeah, or it's also, see that little E above the division sign
Yeah.
over here?
Second division.
Yeah, second division, and we'll see what E, you can see the little E up there on my calculator? And it equals 2.718281828. It's kind of like pi, except that it repeats. Pi doesn't ever repeat. Okay, it's just a number, and so, but in order to put it in your calculator, we're going to have to use that second division. What's the equation for y1? What would I write here?
2e squared.
2e to the x, okay? And then what about y3? What would that be?
0.5.
E to the x, okay? E is your B, and E doesn't change. So the B is not changing on this one, but the A is changing. We're going to see what happens when the A changes.
But how do you know it's 0.5e?
Because I told you the A was 0.5.
Oh, okay.
We're getting them from these numbers over here. That's where we're getting them from. Okay, does that help?
I got you.
Okay. All right, so let's go to y equals and put in 2 second division rooftop x. That's how you do that. And then 3 second division rooftop x. And let's just compare these for right now. Don't put 0.5 in. If you have, clear it out. We'll put it in a minute. We're going to graph just these two. Y'all ready? A went from 2 to 3.
It got a little bit there, steeper.
It did, didn't it? A little steeper. Okay. So when A increases, the graph gets steeper, or the graph is, this time we're going to put vertically stretched. When A increases, the graph is vertically stretched. Okay, now that's 0.5. We're going to see what happens when it decreases. Okay, so we're going to put 0.5 second division rooftop X.
It's water, excuse water.
Okay, so when it's less than 1, it's when A is less than 1, it is vertically compressed. So let's just put vertically compressed here. When A was greater than 1, it was vertically stretched. And also, notice what point is it going through? Like the first one, the 2e to the x, it goes through what point on the graph?
It's like
Right here. Right here?
Oh, it's a 2?
It's a 2. It's going through 2. And then the 3e to the x goes through
3.
3. There you go. And then the 0.5e to the x goes through 0.5. So the A tells you where it's going, crossing the y-axis, the y-intercept. Okay, number 4. What equation would you write on y1? You've got A equals 4 and B equals 0.5.
4x.
4 parentheses,
0.5.
0.5 to the x. I usually put my x on the outside. For some reason, they put it on the inside. I like it better on the outside. Okay. And then, how about y3? What would that be?
0.2 parentheses 5.
Negative 2
Negative 2.
parentheses.
0.5x.
Go to the x. Okay. Just do y1 and y2 for right now.
Miss Walton.
Uh-huh.
Can I go ask Miss Hadley some questions about this review?
Uh-huh.
When's it in 6 weeks?
Next week?
There's 2 weeks. There's 2 more weeks.
Oh, Miss Sides said that if you can, she wants that evaluation today.
Okay, even though she knows there's 2 weeks left.
Yeah, I was like.
Did you
she was
tell her
like,
that?
Yeah, and I was like, yeah, she still has it on her desk, and she was like, oh, well, we wanted it turned in last week, Wednesday.
I know, but it's like halfway through the 6 weeks.
I don't know.
Yeah,
Okay.
Miss House is weird about that. She said like we had like 8 weeks in this 6 weeks.
We have 7.
7. Well, then,
I wonder if the
I-
swap-
Oh, well, we had 8 if you include spring break.
I wonder if
Yeah,
it's water.
But she wants it early anyway.
I know, and I was kind of like,
Okay.
'cause I wanted her to check in.
And that's why I was
She
like,
said
when
we
I
had
took
our
pictures
I
of
was
you
like,
today, I didn't have them all.
PowerPoint.
oh, our
That's
pictures.
really weird.
Or
I guess-
pictures?
Yeah.
So she's thinking since there's already been 6 weeks, even though one of them was spring break, that.
My test was Walker, too. That was
Yeah.
Walker.
Okay. Anyway, we got one of them in there. Okay, 4 times 0.5 of the x and 2 times 0.5 of the x, and then graph it. Why is it decaying?
That's the 0.5.
Right. This b is less than 1, so it's decaying. And it looks like it starts up here at 4 and then goes down, and then it goes through 2. Doesn't it? Okay, so what happened as A decreased, what happened to the graph?
Wider.
Let's say the graph vertically compressed. Now, the most important thing about this one is the bottom one. So I'm going to go back, and I want you to clear out the 4. And in y1, let's put the -2. Parentheses, 0.5 to the x. What's it going to do, Albert?
Flip over the x-axis.
Yep, it sure is.
-2.
It flipped over, didn't it? And go through, and it went through -2. Okay.
Oh, yeah.
Alright, so now we're going to put when A is negative. What happens to the graph?
Flipped over the x-axis.
I'm going to say reflects over the x-axis. Okay, now, these two graphs up here, are those growth or decay?
Okay,
They're starting at the top and they're going down,
okay.
so that's decay, okay? Now, just because this one is flipped over doesn't mean it changes. If you flip it back up, it's decay, all right? So if something is flipped over the x-axis, you got to flip it back up to decide if it's growth or decay. All right? Okay, we're going to do number 5 on the back, and then we're going to skip 6 and finish at the bottom. Okay, we have in this one, and what's the A in Y2?
2.
What's the B?
3x.
Just 3. Just the 3. And then what do you think the K is?
1.
And the A is
2,
B.
3, -2.
So what do you think that 1, that plus 1 is going to do?
Move it up the graph.
Okay, and what do you think the minus 2 is going to do?
Move it down.
Now let's see if that happens. Okay, so we'll put 2 times 3 to the x in the first one. You can just use a times button. And then 2 times 3 to the x plus, whoops, I didn't have my free rooftop x plus 1. You don't need parentheses or anything. And 2 times 3 to the x, whoops, put it on the same
Put
one.
minus the negative.
Minus. Okay, let's do that. That's a minus. Okay. Interesting, huh? Okay, the first one goes through 2 on the y-axis. The second
This one's
one,
really weird.
what did the second one do?
Moves up one.
It moved up 1, didn't it? And the third one moved down how many? 2. Let's go ahead and graph it on the. I don't graph this very well. Okay. You were right. It did move up 1, and it did move down 2, didn't it? Okay, so adding 1 and subtracting 2 shifts the graph how?
Up or down.
Up or down? Or you could say vertically. Okay, I want to talk a little bit about these graphs just for real quick. Okay, there is an asymptote here that keeps that graph from going down below it, right? This asymptote is at 0. This asymptote up here is at 1. I'm not drawing it very well. This one is at -2. Okay. Okay, so there's not anything out here for k, and the asymptote is at 0. The 1, the asymptote is at 1. This k for the -2, the asymptote is at -2. So this tells you the asymptote also, the k does. Okay, down here, we're going to summarize and be done, okay? If b is greater than 1, that was these, does the graph increase or decrease?
Increase.
Increases. Is it called growth or decay?
Growth.
Now, b is between 0 and 1, like 0.6, 0.8. The graph decreases, and that's called
Okay.
All right, and let's look at the k, since we just did the k's up here. What happened when k was greater than 0, or it's like 1 or 2 or 3? Okay, shifts up. It's like adding 1 or 2 or 3. When k is less than 0, that's like subtracting 1 or 2.
Stays at 0. Right?
No, less than 0,
Shifts
remember?
down.
Oh,
Shifts
okay.
down. Now the next one's a little tricky. You don't know it probably. We're saying that the k right here is the asymptote. So the equation for the asymptote would be, like for this one would be y equals 1. For this one would be y equals -2. For that it would be y equals 0. So right here, y equals k, that's the asymptote. K is your asymptote. Okay, then A is greater than 1.
Left or left.
Remember what happened and when A increased and got bigger than 1?
It became vertically stretched.
Vertical, it's a vertical stretch. Okay, when A was less than 1 or between 0 and 1, that was like this 0.5 one. It got wider or vertically compressed. So this is a vertical compression. You have to squeeze that in there. What'd you say?
She gave you dictionaries.
Oh,
If you miss those tests, you have to redo them.
I don't know. I don't know.
Just
Yeah. If you mess up on the test, I believe you have to go to the tutorials
You need to practice this stuff.
if you don't pass it.
Okay.
We don't
The
take
difference between
Are we gonna have to be
a
here?
sophomore and a junior.
Do what?
It's the difference between a sophomore
No, you don't
and
have
a
to be here
junior.
till like
I don't
12
know.
o'clock.
Sophomores have to do that. But.
Yes.
When is this?
Yeah.
Because I mean, if I didn't,
I think juniors is a.
We don't have to be here till 2?
Yeah. So no, 1:50.
It's like,
1:50.
come on.
So it's, we have to come back for this class?
They normally let us out like 2
No,
minutes
okay,
early.
Monday, you're coming back. Instead of coming to 7th and 8th, you're coming to 5th and 6th during 7th and 8th.
I thought it was third.
No, that's
Tuesday.
Tuesday.
We're not going to go to 7th and 8th. You're going to come back after lunch and go to 5th, and then you'll go to 6th.
Oh, on Monday and Tuesday?
No, Tuesday. You're going to go to 3rd and 4th.
During your 7th and 8th period.
Yeah.
Oh, nice.
Okay. So I
Easy
won't.
classes.
I won't see you till Wednesday. Okay.
Yes.
Okay. A is less than 0. That means A is negative. What happens when A is negative? You remember?
Flips over
Or difference.
Yep, it flips over the x-axis. That's right. Usually negative makes something flip, doesn't it?
So what we say?
I'm going to say x-axis reflection.
I just put flips over the x-axis.
That's great.
Are you
I
done?
like that too. We're almost done. We got to do these graphs in. Then we're done. All right. We're going to look at this graph and we're going to tell what A is doing, what B is doing, what K is doing. Okay? Now, what does that one look like? Has it been?
A is less.
It's decay.
It is less than 0.
It's flipped, isn't it? Normally it would look like this, right?
Yes.
But it got flipped over. So A has to be negative, which is less than 0. Okay. Now, B, that's whether it's growing or decaying. Okay.
That's
You got to flip it up, back up, to tell whether it's growing or decaying. So when we flip it back up, what is that doing?
it's growing.
Growing. So is B less than 1 or greater than 1?
Greater than.
Greater.
Good. Now K is your asymptote.
Equals 0.
Good. This asymptote is right here at 0. Okay, now is the next graph flipped or not?
No.
No.
No. So what is A?
Greater.
Greater.
It's positive, greater than 0. Okay. Is it growth or decay?
Right.
Growth, so B is.
Greater than 1.
Now, is K at 0 or did it move?
It's greater.
It moved up, didn't it? So it is greater than 0. Okay, now this one, is it flipped over?
Yep.
No, it's flipped over this axis, but not the x-axis. Okay. So A is still greater than 0. It's not flipped over the x-axis. Is it growth or decay?
Growth.
Okay.
Okay. Is it?
Okay.
It starts up and goes.
Oh, okay, okay.
So if it's going down, it's decay.
Okay,
Alright.
so it's less than 0.
Right. And K, is K at 0?
Less than 0.
Yep, less than 0. Everyone's